Good day, folks. Welcome to the IT Way. My name is Joan, and today we're going to continue talking about troubleshooting, especially troubleshooting VPN. So in the previous video, we did a troubleshooting session with client VPN. So in this one, we're going to talk about Non-Meraki VPN peers. So a Non-Meraki VPN peer is one that you establish a VPN tunnel with an MX Security Appliance to another vendor VPN peer. So if you go to Security Appliance and side-to-side VPNs, you will see that section below. What we're going to do is give you the power and the knowledge to troubleshoot any scenario that you might have or any problems that you might encounter with Non-Meraki VPN peers. And all the power that you need is already on the dashboard. We're going to go and take a look to the event logs. We're going to go and use the live tools, and we're going to take packet captures. So throughout this video, I'm going to say different scenarios that you're going to see you might encounter during your troubleshooting series. And you can see us here. Probably could be that the VPN peers cannot talk to each other. Could be that there is a phase negotiation issue, there is a misconfiguration. Some of the subnets might not be able to advertise correctly, and there are other instances as well. So at the end of the video as well, I'm going to give you the overview of what is the whole process for the phase 1, phase 2, the agreement, the subnets, and you will see the complete traffic flow of what is a good and healthy VPN connection. So let's take to it and let's do it. So today we're going to see how to troubleshoot the Non-Meraki VPN peers. We're going to go through different scenarios, and first we're going to go to the first scenario. But before, we're going to have an overview of the VPN configuration. So you know that to go to this side is going to security and SD-WAN, side-to-side VPN. So here you have the side-to-side VPN configuration to turn it off, turn it on, and this is for auto VPN purposes. So since we are focusing completely on VPN for Non-Meraki, you can go to organization-wide settings, and you will see the Non-Meraki VPN peers connection. So this is our configuration, the one that we're going to use today. The name of the VPN connection. Here it goes the public IP address. In this case, since I've built everything in my lab, I'm going to use this IP address, which is the other vendor VPN peer. We're not using remote ID, and the private subnet from the other side is this one. It means that this is the local subnet in the other Non-Meraki VPN peer. The one that I'm going to advertise from this side is this one, 192.168.1.0. So this is the configuration that I have to put in the other side, and this is the one that has the VPN on. For the IPsec policies, it's the standard one, a basic one, the phase 1 and phase 2. We're going to go through it if it's necessary. And the availability is put to all networks, so that's not going to affect anything of my configuration. So right now, since everything's configured in the other side and we know that everything's configured correctly, what we're going to do is troubleshoot any instance that happens just with the event logs, the packet captures, and the live tools. So right now, I know that this is the private subnet on the other side. For me to trigger to enable the VPN tunnel connection, I'm going to pin to the same IP address .1, which is the gateway in the other side. And then I'm going to come here. I'm going to use the live tools for that. If I have a ping coming through, it means that the VPN tunnel is up. As you can see, the loss rate is 100%. So I'm not able to establish a tunnel or ping that resources. What I do after that is go into the VPN status to see if the VPN tunnel is up or not. Here, the Non-Meraki VPN peer, it shows you if the VPN is up or not. So here we can see that it's red. So the VPN is down. For me to understand why the VPN is down, I go first to the event log. The event log for these particular problems, you will see is the event tab is Non-Meraki client VPN negotiation. So if you are trying to establish a VPN negotiation, you will see that message as well. For us, to ensure that we are seeing the proper message, is going to be depending of the IP address that I'm using. So right now, this is my MX IP address, and this is the Non-Meraki IP address. So if you go through the messages, you can see that it's starting to initiate the phase 1 negotiation between the two, uses the 500 UDP port, is expiring, and now it says the phase 1 negotiation failed due to time up. So now we can see that the problem is coming from the phase 1 negotiation. To corroborate or confirm that, what we can do is taking a packet capture while we're doing the pins. So we're going to trigger the establish the tunnel, and we're going to see if our MX is sending the 500 and if the MX is receiving the 500 traffic coming from the other side. While we're doing the pins, we're going to take a packet capture. So going again, what we're looking for is seeing the 500 UDP traffic coming from our MX to the Non-Meraki VPN peer. In this case, the destination IP address should be this one. And if everything is going through, I'm assuming that I'm receiving the 500 UDP traffic as well coming from this IP address. And that way we know that there is bidirectional traffic in the phase 1. We're going to stop the packet capture, and then we're going to filter it out. The filter that we were going to use is the IP address of our Non-Meraki VPN peer. So here, as you can see, I can see the source is coming from our MX to the destination, which is the Non-Meraki VPN peer, and it's using the 500 port and 500 port. And this can be seen as unidirectional traffic. It means that something upstream either is upstream from my device, MX, or upstream of the other Non-Meraki VPN peer is blocking this traffic, 500. I'm just sending my traffic, but I'm not receiving anything. And that can corroborate then with the event log that we see that the phase 1 is timing out because we're not receiving any traffic coming from the other peer. Now that we know that was something upstream that is blocking, and let's assume that it was a router upstream that you were having that was blocking the 500, and we remove that ACL upstream. So now we know that the 500 should be enabled on both sides. So we're going to do the same process again. Assuming that everything is fine, we will go to trigger the VPN tunnel to be established again. So we're going to pin the internal resources from the other side, which is 100.1. This will trigger to VPN tunnel to be established, and then we can see there is loss rate. So there is a problem still going on between the two. The first thing to go through is the event logs. So let's see what the event log says. The event logs, remember taking the newer event logs and check to see that's the event logs corresponding to your VPN tunnel. To go back, we know that the IP address in this case is the VPN peer on the other side is 50.194. So if we go to the event logs, we know that these event logs are from our VPN tunnel. We can see that the event logs are exactly the same as the previous event logs from the previous behavior. So we know there's something wrong with the phase 1 still. Now we know that we clear everything upstream for the 500, which is the phase 1. So we take the packet capture while we're trying to establish the tunnel to see what is the problem upstream. To see if there is a problem is upstream or something that is misconfigured between the two. So coming back, we know that we have to see the traffic coming from this IP address to the other IP address of the other peer, 194. I know that I have to see the traffic coming from my MX Security Appliance to the Meraki VPN, to the Non-Meraki VPN peer on the other side. I can see the traffic coming from the other Non-Meraki VPN peer to my Security Appliance in the 500 for the packet capture. So having this packet capture, let's open it up. In this packet capture, we're going to filter out with the IP address of the other VPN peer, which is this one. Here in this instance, what I did is I make a continuous ping. In that way I can understand and know if there is bidirectional traffic of each VPN peer can read each other. So here you can see that yes, they can read each other. That's one testing. So now we're going to remove all the pins and we're going to concentrate just in the communication between the two VPN peers. Here you can see the first packet, which is our security MX trying to build the tunnel to the other Non-Meraki VPN peer. And you can see the response from the other side, traffic from our VPN peer, traffic from the other side, and response as well from our side. Here you can see that there is bidirectional traffic. So it means that the ports for the 500 on both sides are completely open, so they can talk to each other. But for some reason, we don't see any traffic from the 4500. It means that we can corroborate with the event logs that there is something wrong with the phase 1 negotiation that is not allowing both peers to go through. Now we're going to identify which part of the phase 1 is the one that is causing this behavior. To do that, we're going to go to the first packet and we're going to expand everything that we have here so we can see what is the negotiation that our security MX is sending to the other Non-Meraki VPN peer. And you can see it here. We can start here with the IK attribute, and you can see the live direction here is 28800, the same thing that we have in our side. The encryption part is AES and it's 128, which is our configuration. The Preshared key and the hash algorithm is SHA-1. So this is what we configure already from our side. So let's see what the other side is providing to us as a proposal as well. The same place, the live duration 28800, the encryption algorithm is AES and it's 256, the Preshared key and SHA-1. So if we see here, if you focus on AES, here it says 256 coming from the other side. And if we go to ours, it's 128. So here you can see in the same packet capture that there is a mismatch in the negotiation between the two. They start talking, communicate, and stop. And if you take the packet capture for a longer period, you're going to see that it's going to start doing all over again. So definitely there is something between them, and is this that was configuring correctly. And that's how you can identify it when you come here and see it here in the packet capture and see it in the event log as well. Here we will continue seeing different scenarios after we know for sure that the phase 1 parameters are correct. So we're going to do the same thing, trying to ping from the other side. Here, what we're trying to do is generate that ping of that traffic going through the tunnel, so we can trigger the establishment of the tunnel. Since you can see that it's not working, then we're going to go to the event logs. So in the event logs, we have this information. It looks like that the phase 1 is failing due to time up, but then you can see the ASH request to the public IP address that we have. Ensure that this is the same public IP address that you're trying to establish the tunnel. But here you can see that the phase 1 is going to try to establish. So it looks like the phase 2 is trying to establish. It means that the phase 1 is already gone, or it's already done. But here you can see that the negotiation for phase 1 failed. If you see the pattern, it says initiate phase 1, no suitable proposal, fail, but it's established the phase 1 is starting to establish the phase 2. So it's something between the phase 1 and phase 2 that is not working properly. If we take the packet capture, if we go and take the packet capture, we should see this discrepancy between phase 1 and phase 2 for the 500 or 4500. So remember, we're trying to see is the traffic from this security appliance to the Non-Meraki VPN peer, the 500, the 6 packets, and the 6 packets for phase 1, and 4 packets in the 500, and after that, the 4500 packets. If we open the packet capture, here we can see it. So here, this is the information that we want, the 500 back and forth. And this is the 4500. So if you can see that the 4500 just from our security appliance to the other side. After that, you can see the NAPKeep alive, but the other side is not replying to the 4500. The same thing started here, the 4500 is sending it from the device, from the other Non-Meraki VPN peer, and there is a reply. After that, what you should see is the quick mode, the 3 packets of the quick mode. And here you cannot see it. So it stays in the main mode identity protection. So it stays in this first one, the phase 1 negotiation, and doesn't go to the other side. What that means is that the phase 1 parameters are good, but there's something within the phase 1 that is not working properly, so we can jump to the next phase. And for that, you can see it here. And this is the Preshared key. So if you have this behavior where you can see just the main mode and the informational all the time, but doesn't go to the quick mode for the phase 2, but all the parameters are correct, most likely your problem is the Preshared key, Preshared secret, that is not the same on both sides. And that's how you fix this behavior. Now that we know that the UDP port 500 is allowed on both sides, it means that we are seeing the bidirectional traffic. Now we're going to continue testing to see if we have the tunnel up. What we will do is the same thing. Send a ping to the internal resources from the other side, and that way we know if the tunnel is up or not. Here we can see that the tunnel is still down. To corroborate that, we're going to the event logs to understand what the event logs are saying. If you come here, you see that the event logs changed. So now we can corroborate that there is something different happening. If you go here, remember trying to check what is the IP address of the event log, because this could be another Non-Meraki VPN tunnel or could be another client VPN negotiation that you might have. Here we know that this is our VPN peer on the other side. So we can start from one of these ones, and says that initiate the phase 1. It means that the phase 1 was going through. The IACN camp was established. It means that the phase 1 was going through. Initiated the phase 2. It means that it's talking the 4500 as well. And in the phase 2, there was no proposal chosen. There was no proposal received and informational exchange. So it looks like when the phase 2 started, either we don't receive any phase 2 from the other side, or we send a misconfiguration in the phase 2 from the other VPN that didn't allow the other VPN peer to send us traffic. To corroborate that, the best way to do it is through packet capture. So we're gonna start a packet capture while sending interesting traffic, so we can see the whole process going through the packet capture. Remember that you have to go here, understand what is the IP address of the VPN peer, and then you're gonna filter the traffic with that IP address. What we want to see is the 500 traffic first. It's gonna be 6 packets for the phase 1 and then 3 packets for the phase 2. You're gonna see it identified as identity protection main mode, the first packet, and the quick mode for the second packets, for the second phase. Let's go here, stop it. And let's open in this one. So if we filter it, here we can see it. Here you can see the 6 packets of the phase 1, which is correct. So we're gonna go through it, the same thing that we did it last time. And we're gonna see it. So the first packet, you can see there is the initiator. So we are the initiator, the 206, because we send those pings. And there is no SPI as the responder. It's the same thing that we discussed before. All the proposals is the reply from the VPN peer, responder SPI. You can see it, and you can see all the proposals. So if all the proposals are fine, it's going to start sending the key exchange. So you can see the key exchange data here, and then the hash of the address and port. So they're going to start to send encrypted data to see if they can pass it through with the same SPIs here. So you can see the key exchange here. You're supposed to see the reply, the same thing with the key exchange. Now you see that is in the other phase. Is going through the same process. So at the end, the traffic is going to start being sent encrypted. So you can see that it changes for the 4500 before it was the 500. So now you can see that all the traffic, you don't see too much, and it's encrypted data. If everything goes well in the last phase here, or the phase 1, the last part, you can see there's the same thing, the SPIs and the encrypted data. After that, you should see an informational, and that's okay. And you should see the 3 quick mode for phase 2. This is the first quick mode, which is from our security appliance, sending the same thing with the SPIs. You can see that here the traffic is encrypted, and it's gonna send the encrypted data. The next packet should be a quick mode coming from the other side, and you don't see it. What the other side is sending is the same as before, in informational. And then an app keep alive because it's waiting to get that information, and it looks like it's not getting the proper information. You can see that again it's sending informational, and then we are starting sending the informationals. And again the same thing. We're gonna try to initiate this phase 2 with a quick mode with all the information previously, and still there is no quick mode response from the other side. So definitely there is something in the phase 2 that is causing this. And the most likely is a misconfiguration for the phase 2 settings. So in this time, in this scenario, you have to take a look to all these configuration, try to put just once and put exactly the same thing in the other side, and it's gonna be fixed. Now that we fixed the phase 2 misconfiguration, we're gonna continue trying to build that tunnel. As before, the first thing is try to trigger the establishment of the tunnel, pinging one of the internal resources from the other side. We know that is 192.168.100.1, and the tunnel is still not up. To see what is wrong with the tunnel, we go into the event logs again. Here in the event logs, we're going to go to the newer event logs, and you will see here the information that it has. So here, let me go a little bit further back. So previously we have this information. After a phase 2 negotiation, no proposal chosen. And now after that, we know that this is a misconfiguration, the phase 2 items that you can change. Now there is a different information. Here you can see that initiate new phase 2, and here you can see the ESP tunnel established. It means that the phase 2 was correctly configured and the tunnel was established. So you can see that the tunnel was established. After that, you can see the failed to get SA info. So it looks like after the phase 2, the information that you need to create the SAs or the security associations is false or is misconfigured. This we're going to corroborate with the packet capture. So we're going to start the packet capture while doing the pins again. So based on that, it means that if we go through the configuration that we have, it means that the public IP address is good because I have bidirectional traffic. The IPsec policies that we provided here, the phase 1 is good because you can see the 6 packets of the phase 1. The phase 2 is good as well because you can see that the tunnel was established. So it's something inside of the tunnel that is not working properly. And the configurations that we have so far inside of the tunnel is the private subnet. To corroborate that, from the other side, the Non-Meraki VPN peer is advertising this private subnet, and in the other side configuration, they have to know that our security appliance is advertising this subnet and this subnet. So let's take a look to the packet capture and see how it looks like. If we filter the packet captures here by the IP address, and this one is because I was doing pins just for monitoring, we can see almost as previously. You can see the 6 packets for the phase 1, which is correct. The 4500 bidirectional traffic, it means that 4500 is fine. The quick mode, the one that we selected, we highlighted before, coming from the other side, and you can see another quick mode as well. You can see the NAT keep alive and all the information as again. So if you see here, we can see the quick mode from the other side, the NAT keep alive, information all again. So it's exactly the same information as previously. It looks like there is something that is not allowing going through the second quick mode to respond to the first quick mode. But now, since we see that in the packet captures, now we can see this new message. It means that is the pre-process of the phase 2 is going wrong. And to do that and to understand that, it means that this is wrong, or the configuration in the other side, what the MX has to propagate and advertise, is wrong. So checking these private subnets in both sides and ensure that it's the same will fix this issue. Now that we cover all the different parts and the different scenarios, I want to show you when it works correctly and it works smooth. So what we're going to do is we fix all the problems that we had previously, and now everything is well configured, exactly the same thing as the other side. So the way for you to test it is you try to make a ping to the internal resources from the other side. And when you see that it's working perfectly fine, like this one, you can go to the event logs and identify what are the event logs when everything is working fine. So we can go to the newer event logs. This is what you should see. The phase 1 negotiation, everything was fine, the request, and then the establishment of the SAs. After that, initiate the phase 2 and the establishment of the ESP tunnels. And that's it. There is nothing else that you should see. And as you can see, it's working perfectly fine. So if you take packet captures, when you start the pins, you should be able to see all the packets, the 6 packets for the phase 1 and the 3 packets for the phase 2. The beginning of the packets is the 500, then it's going to change to the 4500. After that, you're going to see the quick mode in 4500. And at the end, since the tunnel is established and we're sending pings through the tunnel, we should see all the ESP traffic or the encrypted traffic afterwards. So let's take a look to the packet capture. Here, I make this packet capture, and then we're going to go through it. The same thing that we did at the beginning for the first scenarios. Here you can see the first packet is going to send you all the proposals to talk between each other. The other one is going to provide all the information as well. In main mode, you can see there is the 2, and here it started with a key exchange. The key exchange, the same thing, the reply from the other side. After the key exchange, it's going to send encrypted data. The encrypted data as well, replying from the other side. And this is all the phase 1, and then it started with the phase 2 with this quick mode. So here you can see the quick mode 32, the SPIs for the initiator and the responder, ensure that everything is exactly as the phase 1, and all the encrypted data. You're going to see the reply from the other side with the same information, and the last packet in the establishment of the tunnel is coming from our side with the quick mode as well, the hash and the same SPIs. After that, the tunnel should be established, and you should see all of ESP traffic, that is the encrypted traffic coming inside of the tunnel. So as you can see with the SPIs, everything after that is just the traffic through the tunnel. And this is how you can see a healthy tunnel creation using a Non-Meraki VPN peer and the MX Security Appliance. And that's how you troubleshoot a Non-Meraki VPN peers using the dashboard, the event logs, the live tools, and the packet captures. So you were able to see all these different kinds of scenarios and how to troubleshoot and troubleshoot it well. As in additional videos, I'm going to post all the documentation that you need for further clarification of troubleshooting coming from the Cisco Meraki dashboard portal and the documentation portal. If you need any additional help, or if I cover something that you are experiencing that was not here, please let me know through the comments below. I'm going to help you as much as I can. So keep subscribing, keep liking it to have more videos like this one. And in the next one, we're going to cover the auto VPN troubleshooting section. And that's how it's troubleshooting in the Meraki way. See you in the next one.